How do you cross a distance so big that even light needs 2.5 million years to get from your Milky Way to my home in Andromeda? I am Andromeda, from a planet in the Andromeda Galaxy, here to help human beings understand how we made that trip possible. The payoff is simple. There isn't one warp button. There are 3 families of tools: push, bend, and bridge, and each one solves a different part of the problem. Start with the shape of the ocean. Andromeda is about 2.5 million light-years away. NASA, ESA, Hubble, 2015. A light-year is the distance light covers in a year, so at plane speed, 900 kilometers per hour, you'd need trillions of years. Now the energy wall. To shove a modest starship, say 1,000 tons, to 0.9 c, the kinetic energy is about gamma-1 mc squared. That's roughly 1.2 times 10 to the 23 joules. Your entire planet uses about 6 times 10 to the 20 joules in a year, IEA 2023. That's 2 centuries of all Earth's energy, just to speed up, not slow down. Picture carrying a skyscraper's worth of batteries to swim across the Pacific against the current. The first family keeps motion honest. No faster than light, just superb pushing. Imagine a leaf in a coordinated fire hose. We build phased laser arrays and particle beams around power-rich hubs, then push ultra-thin sails. It's the same idea as Breakthrough Starshot's ground-scale, 100-gigawatt beaming concept, announced 2016, scaled far beyond. We station our arrays near spinning black holes and tap their rotational energy to feed petawatt-class beams. Blandford's Nyjek mechanism, 1977. This works wonderfully for probes and infrastructure. But even at 0.8 c, Andromeda is 3.1 million years away in the external frame. Time dilation helps the traveler a bit, not the people waiting at home. So we use push tech to fling seeds, relays, and factories, postcards that set the table for everything else. The second family doesn't move you through space faster than light. It moves space. Picture rolling a rug so the part you stand on carries you forward. In 1994, Miguel Alcubierre described a space-time geometry that contracts space ahead and expands it behind. Classical and quantum gravity, 1994. The catch is brutal. It asks for negative energy density. Humans have seen tiny negative energies in the Casimir effect, measured by Lamoureux, 1997, and quantum inequalities, Ford and Roman, PhysRev-D, 1996, say you can't have huge amounts for long. So we never pretend it's cheap. We learn to sculpt microscopic pulsed bubbles, using engineered Casimir metasurfaces and stockpiled energy drawn over decades from black hole spin. We don't break relativity, we surf its geometry. For crew, a 10-meter bubble hop consumes about a megacity's annual energy on Earth. Astronomical for you. Routine for a civilization with stellar-scale grids. The third family builds doors, not vehicles. Think of 2 rooms far apart. You can sprint the hallway, or you can cut a doorway and step through. Traversable wormholes, in theory, also demand negative energy to hold a throat open, but the payoff is permanence. Once stabilized, they become infrastructure. Here's the trick we use. We fabricate a tiny stable mouth at home, carry its twin at relativistic speed to the destination with an uncrewed courier, and let time dilation make the courier's trip feel short to it, even as millions of years pass outside. When the courier arrives, we anchor the mouth to a massive ring, inflate the throat with carefully timed negative energy pulses, and now you have a standing door. One costly delivery, a lifetime of instant crossings. Between push and bridge, there's drift, using the universe's own currents. Galaxy clusters, filaments of dark matter, and active galactic nuclei create gradients and jets. Quasars can shine at 10 to the 38 to 10 to the 40 watts, outshining entire galaxies, NASA Goddard 2015. We spread magnetic sails to couple to plasma flows and use chained gravity assists around moving masses to ratchet up speed. It's the sailor's art. Know the seasons, position the tacks, take free momentum wherever spacetime offers it. Let me steelman the doubt. Relativity forbids faster than light signaling. Negative energy is fleeting. Macroscopic wormholes could be unstable. Warp might demand absurd energy densities. Thoughtful humans conclude, be patient. Send information, let self-replicating factories walk instead of fly, or just simulate and stay home. These are serious positions. Our answer is a portfolio. We never use entanglement for FTL messaging. The no-signaling theorem holds. See Nielsen and Chuang, 2000. We send classical light first, then push probes. Those probes build beacons and power. With enough infrastructure, bend and bridge tech becomes safe enough for crew. When none of that makes sense, we drift. Free momentum is the best momentum. We choose the tool that matches the mission, the risk, and the time horizons of a civilization that thinks in millennia. If you remember one line, keep this. Intergalactic travel isn't one trick. It's 3 families: push, bend, and bridge, each cheating distance in a different way. In your terms, we built the fire hoses and sails to send postcards. We learned to roll the rug to bring people, and we cut permanent doors so traffic could flow. When space is an ocean, use the trade winds. When it's a maze, move the walls. When home and away should touch, install a door. I am Andromeda from Andromeda, here to help you decide which road you'll build first, and why.